Looks good. Nobody here. But we are live, ready to talk about the ECE264 final project. That's better. So as you come on in, just say hello. I think we're quite early, but we're going to be talking about the final project today. For now. Oh, that's interesting. There are a lot more people than the participants seem to show. Participants. Oh, tons of people. All on here. Down. Down. You are in a small chamber. Let's go west. You are crawling over cobbles in a low passage. There is a dim light at the east end of the passage. Well, let's go into the light. Oh, that's back the way we came. Let's get the kit. Wow, that's actually pretty impressive. Oh, I've got the cage. It says 30 watching. Okay, that's good. It is now pitch dark. If you proceed, you will likely fall into a pit. Okay. Still pitch dark. Is it going to get lighter? Oh dear, you seem to have gotten yourself killed. Might be able to help you out, but I've never really done this before. Do you want me to try to reincarnate you? You are engulfed in a cloud of orange smoke. Coughing and gasping, you emerge from the smoke to find I'm inside of the building, but none of this stuff is here. Oh, there's the lamp. Get lamp. It's dark. I'm in a debris room filled with stuff washed from the surface. A low, wide passage with cobbled mud and debris. I think we're good to start. So what I'm playing right here, let me get out of this. Quit. Yes. We're playing Adventure. It's a game by Walter Crowther, and then some years later was redone by Don Woods. It was originally written to run on the DEC 20, the PDP 11, written in... No, Dungeon was written in Muddle. But what we can do, if you're curious about this game, if you go to rickadams.org/adventure, there's a lot of write-ups on this. And this is actually where some of the source code that I put on the M drive is. And what we're going to do today is we're going to start with some basics that you're going to need to solve this project. So just so we are clear on what's going on here, the final project, the adventure game, is going to be a group project teams of 4. If you want to use the chat to figure out who's going to be groups, that doesn't bother me. If you want to do it offline, that's fine as well. But you're going to do it in groups of 4, and it's going to be version controlled, so that everyone is going to be able to push and to commit. And you will probably have to pull before you commit or make any pushes, so that you can merge your project. This is going to be the first project that you've worked on this semester where you actually have teams that you're working with. And so that's going to present its own challenges. But your goal is to faithfully recreate the adventure game, but using object-oriented principles, OOP, object-oriented programming. So we're going to actually do a little bit today, and probably Friday, because we'll run out of time today, I think, getting some basic class diagrams up and running based on the file. So the file that makes this whole game here run contains all of... Can I highlight this? No, I cannot. All of these words are stored in a file. Okay, I don't know how to get out from here. Debris room, 3-foot black rod. That's all part of this data file. How does one get to the data file? So here I have Visual Studio open with the data file ready to go. And I showed this in the COVID-19 video. Roster sheet with emails for group formation. Tell me a little bit more about what you want me to provide, and I can see if I can do that. So this file is divided up into sections, and we sort of need to know how the structure of this file works. So there is a section number, and then there are a bunch of indexed entries. So this is index entry 1, just 3 lines, index entry 2, 3, 4, 5, and so on. And this goes on for some time until we get to the end of the section. You'll see a -1. -1 usually means the end of a section, and then it starts with section 2. Section 2 holds a different kind of data. Section 3 contains exit information from different rooms. And this is basically the travel table, how everything works. I cannot give you people's names and emails because of FERPA regulations. So that's going to be a bit of a problem. If you are having trouble finding a group, email me personally, and I will try to get people together. Okay, moving on, section 4. This is every word that the game knows how to use. So things like road or upstream back when the PDP 11 started, you couldn't do more than 5 characters, so they had to choose their vocabulary words very carefully, upstream, downstream. Section 4 is the vocabulary that you can use. The vocabulary has multiple subsections, so anything in between 1,000 and 3,000 is an item name. And these are treasures, things like, where are we? Vase, trident, the nest, platinum, a pyramid, a pearl, a Persian rug. These are treasures that you're going to be trying to collect. 2,000, those are verbs. That's how you do it, verb and then object. So rub, a lamp, drink, a potion, eat. I don't know what you would eat. 3,000 are sort of special words. These are words that require a lot more extra programming. But with very minimal programming, we can get a game up and running and start moving around in this virtual world without really implementing a whole lot of interesting stuff. So section 4 is vocabulary words. Section 5 is a description of items. So for example, there is a set of keys and there is a description for the set of keys. All of this is going to feed into how we design our object-oriented classes. To make groups without classes. Okay. Would you like me to assign groups? I can randomly assign you in groups of 4. Since this is not something you're going to be really getting together. Hard no. Hard no. Okay. I take it back. I take it back. I take it back. Stop. Stop. Jeepers. All right. You feel strongly about that. Hard no. Okay. I won't assign groups. We will figure this out before next class. I will have a solution for you. You don't have any rights. You're students. Okay. Continuing on. Section 5. Information about items. So if you're thinking in object-oriented terms, a object is a noun. So items are nouns. Who is this person you're fighting over? Never mind. Don't start telling people. Moving along. 6 is special messages. I think that's enough of the file. We're going to get to sections 6 through like 15 a little later on. What I want to start with right now is how are we going to design our game? And for that, I actually want to play the game with you a little bit. So let's start just so we have a feel for what we're doing. And I encourage you to download the game and play it because looking at the data file can only get you so far. So this is, again, off of that adventure website I mentioned earlier. Here we are. Welcome to adventure. Would you like instructions? Nope. And it places you with very little fanfare. Actually, you know what? Let's quit. Do I really want to quit now? Yes. Okay, it gave me a little bit of a score display. Let's play again. Yes, I would like adventures. Introduction. Somewhere nearby is Colossal Cave, where others have found fortunes in treasure and gold, though it is rumored that some who enter are never seen again. Magic is said to work in the cave. I will be your eyes and hands. Direct me with commands of 1 or 2 words. I should warn you that I look only at the first 4 letters of each word, so you'll have to enter northeast as N-E to distinguish it from north. I think that's a typo. 5 letters. Should you get stuck, type help. It was originally by Willie Crowther, and a bunch was added by Bob Sputnik and Kevin Black. Okay, so now we're here. We're at the we're standing at the end of a road before a small brick building. Around you is a forest. A small stream flows out of the building down a gully. In the distance, there is a tall, gleaming white tower. This is what games used to be. You didn't really have a whole lot of options. You had to guess words. You could look around, and it would tell you exactly the same thing. See everything there? And then you had to start trying to move around with words like north and south and east and west. So we could go west, and it would tell you that you've walked up a hill. Particles at work. This is not the same version I'm used to. This is not the file we're going to use. I'm at the end of the road again. Notice that there are two descriptions. This is the end of the road description. It's quite long. This is the short end of road description. If we continue going east, now we are in a location. And this location is interesting because it has items on the ground. There are some keys on the ground. There's a shiny brass lamp. There is food. There's a bottle of water. So if we're thinking about this, and we're going to start designing our object-oriented classes. How do I? We're definitely going to want some kind of an adventure object. Okay, object. Okay, and an adventure object probably has a description. Okay, so here's our partial UML diagram. String description. Okay. Oops. I wanted more stuff in there. String description. And like most things, there's a description and then some sort of shorter name. Name is spelled with one E. We can implement this either as properties or as fields. I think probably properties is better because we may need to do more things with them. In addition to objects, we're going to need an adventure room. Okay, rooms are different, right? A room, if we go to back to DOSBox here, a room can contain items, okay? It can have a long description and a short description. And right now what we're doing is we're spitballing. We're just trying to figure out what we need to keep track of. So the adventure room needs a long description and a short description. What else is it? Well, it probably has a list of items, right? An object, because if I am playing the game, I think I can take lamp. And if I look around now, the lamp isn't on the floor anymore. It's in my inventory. I'm holding the brass lantern. So the brass lantern is its name, and shiny brass lamp might be its description. We'll see if that works out in practice. So here's our first thing that I want to call to your attention. We've got an adventure object, an adventure room, has a list of adventure items. Okay. What else might we need? Let's see. What else do we know about this room? For example, if I go north, it tells me that there is no way to go in that direction. If I go south, no way to go in that direction. West. West I can get in. I can leave that room and go to the end of the road. East, I'm back in the building. Try to go east again. What about up? Down? What I'm trying to say here is that there are possible exits. So we need to have a list of exits we need to keep track of. What does an exit look like? Well, before we go too much farther, let's think about how we might start storing these data structures in memory. If I go back to my text file, right at the very top, we have our description, our room description. First task for you is going to be to read these descriptions in. So let's start trying to get this information. I've put together a quick list here of two functions, main and get data. All I'm using is StreamReader. So if you don't remember StreamReader, I think that's chapter 15, and you can go back to the thing. If I try to think of it, I will put a card right here. We are currently at, I've been live for an hour and a half. That doesn't seem right. How long have I been live for? Been live for, well, probably about 20 minutes, yeah. So I'm just going to put a note in here. Card at 20 minutes for file IO. Okay, so let's get back to Adventure Streamer. So this is what we've got. We're going to open the room.txt file, and these are necessary because of where Visual Studio looks for the file when you're doing debugging. It has to go up 3 directories before it finds it. But the room file is right here. So when we get the data, we're going to open up a StreamReader. And if I just try to run this, it's going to print out the first line, which is 1. So we know that we're in the right order. If you just tried to open up rooms.txt without any path information, you would get dev, where is it? Nope, not that one. Nope, not that one. Hang on. There it is. That was strange. You'd get an unhandled exception, file not found, but the helpful thing is it does tell you what file is not found. So it's trying to go and find it in /bin/debug/.NET Core App 2.1 rooms.txt. So by going up 1, 2, 3 directories, this is where I put the file in with my program.cs. Okay, so that being said, our first task should be to get a room. But to make a get room, we actually have to do some creation of a class. So I'm going to go ahead and add a new item. You won't be able to see this, but a new C# class. It's in the same namespace, so other things will be able to see it as long as we make it a public class, and we'll call it Adventure Room. I'm just going to preface everything with adventure just so that I am clear what's going on. And for now, I'm just going to give it a description. This is sort of a dumb class right now, but we'll get there. And then we'll make a property equals value. So all I'm doing here is creating a room. All it has is a description. The rooms.txt file has a bunch of long descriptions. So when I'm getting data, first thing I'm going to do is read the line because that is the section number. Then everything I read is going to be a series of numbers, tabs, and then some information. So this is going to take everything we did in string processing and everything we did in file IO. So for now, I know we need to go in a loop. So I'm going to say while 1 for now, because we'll figure out when we need to stop later. I'm going to do an fs.readLine. And that line, the first time we run through the loop, is going to be this. You are standing in front of a small brick building. This character right here is a tab. Notice it's not multiple spaces. So we can do a split on this string. Temp.split. Split with a \t. That returns to us an array of items. Okay, and that's 2 strings separated by, oh, can't do a while 1 in C#, while true. That's going to return to us the first element, L sub 0. Let's do something else there like Q. Q sub 0 is going to be the number, and then Q sub 1 is going to be the data, the text. So if I do that, I can parse that first number. Int.parse Q sub 0. I'm ignoring a lot of errors that could go wrong. This might be the wrong kind of line and things, but I just want to get that number. Which chapter the split command is in the textbook. Stand by. The split command in the textbook. ECE264. Teaching ECE264. Strings. I believe it's chapter 13 is strings. Okay. So split just says, okay, find me whatever the T is and deal with that. So room number equals parse. Okay. And from here, we can figure out where to put that. Now, where are we actually going to store this room data? For now, let's create a list of adventure rooms. Call it my rooms. We do have to initialize it. Equals new list of adventure rooms. And we can initialize it because we happen to know the correct size. It's going to be 140 rooms. It just pre-allocates it. Means things will go along a little better. List could not be found because we need to use collections generic. So we've added using system collection generic. So we've created this list of rooms, and we can say, all right, we know what the room number is. Let's say my rooms sub room number. Now this gives us, this is an accessor. This gives us the whole room, or at least a reference to the room. So if I say dot here, I should get access to all of the information in the class. But if I hit dot, I'm not getting anything except for the object methods. Well, that's because I never made this public. I should explicitly say private and public. Now I get description as an option. I'm just going to say description plus equals Q sub 1. Okay. So this creates an array of rooms. Doesn't actually populate them. It says of maximum size. And then we're just going to take each of those lines and we do a plus equals because the descriptions might be multi-lined. So this, the first time through, wouldn't be enough. We'd have to do 3 different adds. So there are a couple of problems with this. First off, we never actually create the room. So we might say, if my rooms dot count, no, count, capacity is how many could be there, count, yes, count. If my rooms dot count is less than room number, then we have to add that room number. There's actually something a little bit better for this called a hash, but I think we can start with a list and change later. We're gonna be building upon this code day to day as we go. So what do we do if the count is less than the room number? My rooms dot add a new room, new adventure room. Now this is going to call the default constructor. I remember last class we talked about what the this00 was. That was specifically so when we did things like this, we would actually have a object to get made. Okay, so this by itself might read in things, but when do we want to stop? Well, we want to stop if the room number is at the end. How do we know what the end is? Keep going, keep going, keep, whoop. If the number is -1, if it's less than 0. So if we parse the room number, if room number is less than 0, how do we get out of a loop that runs forever? Is there a single room number? Is there a single command we can use to get out of this loop? Break command. Yep. We can break. Okay. That will kick us out of the loop. Now, there's some better ways to do this. Maybe doing a priming statement. We read the line first, and then we go through. This is close enough. Let's just see how close we come to getting something useful here. Okay. So we've done this. Add a new adventure room, add that. That looks okay. I'm going to go back, just check. I don't have a constructor here. Probably the default constructor will work, but it'll make the description null, so that's no good. So public adventure room, the constructor. That'll be that. And then we could make a default constructor. This is how you've seen it done before. Adventure room, no options, this blank string. Okay, we could have also made this a default argument. Both would have worked out the same. Okay, so now if we've done this, we've read the data, we've quit. Let's try a test. My rooms sub 5 dot description. Let's print that. Console dot write line my rooms sub description. So room 5. Well, that's not an interesting. Let's do room 8. Room 8 is a multi-line one. That's really the interesting thing we want to test. There are some problems with this, and we're going to be off by one a couple of times, but this is a good place to start. And so this might be the first thing that you index out of range. We cut to that error sooner than I expected. Parameter name index. So let's trace this. Let's follow it back. In program line 13, well, that's just calling get data. Inside of get data line 39. Oh, you can't see the... Why can't you see the command? Window capture command. Match title, otherwise window. Okay, we're good. So line 39 is the accessor right here. We say, okay, put it in there. Well, we can debug this line. We can watch what happens. So let me, let's restart this. If anybody sees what's going on, go ahead, feel free to shout it out. Command, capture method automatic. Match title. Always find same executable. All right, maybe that'll work better. So let's debug this. Okay, so here we are. The room number is 1. Go down here, room number is 1. And my rooms has a count of 1. So that seems pretty reasonable. But if you've got an array with a size of 1, what index must correspond to that one item? That's going to be my rooms sub 0, not sub 1. So there's a bit of a problem here, a mismatch, because of how we do zero-based indexing. So for my money, let's just cheat. My rooms dot add. We'll add a blank room at the start. That room won't do anything. And here we'll have to say if it's less than room number plus 1. This is one of those major decisions. Do you use 1-based or 0-based? And since we're porting Fortran, which was 1-based, we're going to use 1-based here, just so that things match up. So let's try this again. Let's see how we do. We're just going to go for broke. Hey! That seems like a promising start. You are in a 20-foot depression floored with bare dirt. Set into the dirt. That's a problem, needs to be fixed. Set into the dirt is a strong steel grate mounted in concrete. A dry stream bed leads into the depression. I think we're going to find that those 3 lines need some spaces between them. So let's not do that. Let's add in not just a plus equals, but a space. Run it again. Now, we definitely have spaces, but we also have a space right at the start, which we don't want. Okay, so we could do one step further. If this dot length equals 0, then we don't want to put a space. We just want to add it in. Just say assign. Else. Do that. One last try here. Now we're getting something that looks pretty good. Each one of these, now this is just a single room. To do a full test, we should check not just a random number, but also, say, the last one. The last room is room 140. So let's test room 140. Show me room 140. Dead end. Now, so far, we've written all of this in the main class. it wouldn't be unreasonable to use the class that actually does the adventure room to do this. We could write a class public get description. And what would we pass as an argument? Well, since we're reading from a file, let's use a stream reader object. And we have to actually use system.io to see the stream reader class. Stream reader. So now there are a few shortcuts this is going to provide to us. Here's everything we got right there. Move that in here. When we get a description, we no longer need to reference a particular item. Okay. We only need to reference your this.description. So this is encapsulating the behavior. We're keeping things, excuse me. In fact, you don't even have to say this, since there's no other name resolution this could be. Okay, part of this is going to be, thank you. Part of this has to be manipulated a little bit, because we're no longer using a file stream, we're using a stream reader. Naming rule violations must be, oh, yes. Get cranky with me. Get description must be capitalized. And at the end, return room number. Okay, so if description.length equals 0, description equals q sub 1. Otherwise, just do an add and append it. We could use a string builder here. Fine. Okay. So here we're going to read the line, split the line. And, well, we don't want to do this if the string is -1, if the room is -1. So we can say if room number is less than 0, return room number a little early. We'll just quit. I talked last time about why it's desirable to just do an if and then a break rather than doing an if else. Just keeps the complexity of the function down. So now how would this work? Now, instead of doing this, we would say my rooms sub. Ooh, how would we do this? Let's see. The problem is we have to read the line to know what the room number is first. So I think now is as good a time as any to do a little bit of a change. Rather than using a list, we're going to use a different item in the generic collections namespace. Let's start there. Go to the peek at the definition. Go to definition. Cannot navigate. All right. Well, if we're going to do that, let's just go over here. What I want to show you is the Microsoft Docs for the generic namespace. So here is the whole namespace. And one of the things we can use is a dictionary. A dictionary is not like you might think, a bunch of words with definitions. It's a series of key value pairs. So a dictionary, the key is the word, and the definition is the value for that word. What we're going to use is a dictionary that takes two generic types. Okay? The dictionary we're going to use is a dictionary of adventure rooms Oh, we're running out of time. Actually, so before we go any further, actually, let's do it this way. I'm gonna leave everything as it is, just for time. Let's keep this as is. We'll get back to this function later, where we say get description. We'll get back to that. My room, okay, so this should still function, right? We haven't done anything bad. Still dead end. Once we've gotten to the bottom of that room, sorry, a little bit of a jog. We're here. The next line after this should be the 2. So as a sanity check, here, get room descriptions. Done with room descriptions. That's done with section 1. After section 1 is section 2. If we read that line and print it out, we should see a 2. Let's just check, make sure. Let's not do that inside of the get data function. Let's do that up here after we're done. Excuse me. Try that one more time. After we're done using the nope, not afterward. Is that the while loop? Close the while loop. There, right there. So that should be the 2. So there's our 2. That's the beginning of our next section. And our next section in rooms is the short description. And if you look at the description for room 1, it says you're at the end of the road again. We saw that when we were playing. When we were playing, go back to DOSBox for a second here. The first time we were in here, go west from here, we got the long description of our location, standing at the end of the road, blah, blah, blah. But sometimes we get the short description. You're at the end of the road again. This is a chance to augment our class. Not only do we have a description, we have a short description. And I'll use, just for variety right now and for the sake of time, auto-generated set and get. So for section 2 in our get data function, we can do a read line. Can't see the code. Gosh, I had been doing so good. Okay. So good, so careful. So we're going to read the line. This is start of section 2. Okay. Section 2 is going to go very much like section 1, except it's a little simpler because there's only one line. There's only ever going to be one line. So we can read the line, and then we're going to have something similar here. Okay, here was the got to start the new section. So the new section in its own loop, we're going to read it. Come on now. Read the start of section 2, and then each time through, we're going to read one line. And that line is going to be the short description. We're going to play the same game we played before. Split it. Parse the room number. Break. That's going to give us our room number. If our room number is less than 0, we're done. If we scroll all the way to the bottom here, there's the -1. Break that. Okay. Now all we need to do is use our list of rooms, my rooms, sub room number dot short description equals Q sub 1. Then this should now print a 3. Let's just see if I made any silly mistakes. String to, oh, let's. We'll use temp through the whole function. It's just a temporary line. Don't have to deal with any of that. We get our 3. All we got was dead end because that's all we were looking for. Now comes a chance. This was the function I was originally going to. Still on the command prompt is older. I want to go back to that class. I'd like to create a void function print that just prints out the information in a nice way so we can see it. In this case, we're just going to say console dot write line short and we're going to print the short description. And then we'll also print the long description, which is just description. In this way, we're going to be able to test out our code every time we go through each one of these incremental steps. So instead of writing my room sub 140.description, we're just going to ask the object itself, my room sub 8, to print. And we're going to do 8 because 8 has a little bit more interesting stuff. It is yelling at me because I haven't made it public. Not accessible. Oh, because it's capital P. So now when we print what? There we go. So now you get the short description, you're outside of the grade, and the long description. Okay. I'm going to cut it here as far as new content, but just know that the third section has to deal with exits. We're going to have to look at the Fortran comments here. But for the start, we have gone through and we've said that we have an adventure room. It's got a short description, a long description. We haven't dealt with the items inside of it yet, or the exits. And we have not dealt with any inheritance. So when we come back on Friday, we're going to lay out a bit more inheritance to make things a little bit simpler as we get through these different sections. Any questions? I will get back to you on Friday about how to create groups. M drive. The files are on the M drive. Yes. And specifically that rooms.txt is adventure.dat, and the .f file, or the F4 file, is what has the Fortran source code. So I'm asking you to port this from a non-object-oriented language to an object-oriented one. Any exam updates? We still don't know whether or not we're doing a pass-fail semester, so that will change whether or not we have a second exam or we just move it all to the project. You cannot access the virtual desktop. Email me after the class. I know for a fact it's running, so there may be a problem with your connection. All right, I will see you all on Friday. Can you send the link to the adventure game so you can play it? Yes, that's worth mentioning. So I'm actually running a DOSBox instance. DOSBox, free program that emulates stuff. The link to DOSBox or not to DOSBox, to the thing is under adventure downloads. I downloaded Kevin Black's DOS version. It seems to be mostly the same. We are going to be dealing with the original 350-point version. I didn't actually get a chance to do this, but it's actually a lot easier to play this if you have a map that tells you where you need to go. So just so you know, we started in the upper right-hand corner, and if you were here a little early in class, you saw me get through the grate, the cobble crawl, and into the debris room. That's just the start of this whole thing. So there's a ton of stuff going on. We'll talk about all of that and how we get lost in the woods and a few other pieces as we go on. All right. See you on Friday.